partial differential equation, which is much harder to solve than the ordinary differential equation. So any equation contain partial differential coefficient is called partial differential equation. For example, this is the second order partial differential equation. And you can use the function and then get the partial differential equation like this. However, it's much harder to solve, if impossible. So we will look at there are certain partial differential equations that can be solved. We will look at second order constant coefficient equation like this, and then we will look at the separation of variable. So second order constant coefficient equation like this, and you have three different types. If it is elliptic type, is a b minus h squared greater than 0 equal to 0, parabolic, hyperbolic, something like this. So let's see the Euro equation. It can be written like this. And you can see is how this goes. And it can be solved like this. And these are the example. We use Laplace equation like this as an example, and you can see how it's solved. And example 2, to solve this partial differential equation. And this is like before we say, if you put in like u equal to arctangent y over x, and you can deduce like this, and this is where it comes from. So you can see it's coming from here, and it can be get Laplace equation this way. And change your variable. You can change it to different variable like this. And these are the example how you can change the Laplace equation from rectangular Cartesian coordinate to polar coordinate r and theta. This is how it goes. This is how it goes. These are more examples to solve this partial equation, differential equation, and it's a parabolic type. Now we look at the separation of variable. So we will look at three different types. One is one-dimensional wave equation. It's something like this. Second one is one-dimensional heat conduction equation. It's looking like this. The third type is Laplace equation in 2 dimensions, like this. The wave equation, which is can be solved like this. And this is one of the wave equation. It can be vibrating string, and is something is solved like this. These are vibrating string controversy. These are something introduction about different person. And you can see this first solved by the Lambert, then Euro, and then Bernoulli. So wave equation is like this, and you can see is something, this time and this displacement. It can be pressure in a liquid gas or something else, or stream, something like that. This give you some introduction. It derived from Hooke's law of the force, something like this. Spherical wave, something like this. So it can be solved the wave equation like this way. Solve this way. Then let's look at the heat conduction equation. Like this, heat is conducted in one dimension. These are some briefly introduction of this. This is the wave equation. Then you can see this symbol gray is expression like this on a scalar field, and later we will see a vector field. So graph like this, and then you can see the three-dimensional Laplacian. It can be a scale. The graph is a vector, and it's called del square. These are something, if you work on a vector function, A is a vector function, the graph will become a vector, and there's definition of curve, and you can see the curve is defined by this, and eventually you start getting dive and curve, something like that, and eventually there's all kind of operation, and these are more. So the heat conduction equation can be solved this way. And then the last, we will look at the Laplacian equation in 2 dimensions like this, how to solve the Laplacian equation in 2 dimensions. And there are examples. I give you the boundary value. And other method is like a Laplace transformation, but usually it's very hard to solve. So you need to use numerical method. And these are some example. More example. And later on I will show you the computer website to solve the partial differential equation. These are from the website search, and you can see there are free websites that you can do this, solve partial differential equation. And these are some of these methods they use in the website. And this is how to